Polynomials, monomials, one term, multiplying like bases. So when multiplying like bases, you add the exponents, and this is what the rule looks like. X to the m power times x to the n power, they both have x as the base, that's what I mean by like bases, is x, the same base, to add the exponents, m plus n. Even though you're multiplying the bases, you add the exponents. All right, you're adding the exponents there. So x to the fifth times x squared. So this is going to be, based on our rule, x to the 5 plus 2, which is going to be x to the what power? 7. X to the 7 power. Now let's look at this a different way. I left some space up here because what does x to the fifth mean? Right? And you could write a dot between it like this one, or you could have parentheses like this one. So, but when you have x to the fifth, that means, if I come over here in a thought cloud, I want to think about this. I want to think about this in this thought cloud. X to the fifth means x times x times x times x times x. That's the x to the fifth. Times, what is x squared? It means x times x, two of them, right? So you have 5x's times 2x's, and that really means you have what? 1, 2, 3, 4, 5, 6, 7 total x's all multiplied together. So that's where we get x to the 7th from, because we're multiplying 7 x's together, which is the definition of x to the 7th power. Okay? So think about it writing it out. Now you obviously, if it gets really big, you don't want to write out 47 x's and then 33 more if you're doing 47th power and 33rd power. That's why we have the rule of add them together. So here, m to the 10th times m to the 4th, whether you write it with a dot or with parentheses, or here even with the c's with nothing between them, you're still multiplying those things. In algebra, when they're written beside each other like this, they're multiplied. So this is going to be m to the 10 plus 4. Now, I'm a huge fan of you writing that. All right. In my classes, when possible, I can give partial credit, right? So if you show me this step right here, then I know that you know what to do. Now, in this particular class, maybe I don't let you use a calculator, but then you say m to the 14th, and then you get the answer completely correct. But if you show me this step here, and then you tell me 13 because you can't add 10 plus 4, then I go, oh, they knew what to do. They just couldn't add 10 plus 4. All right? And you may laugh at that, but, right? What happens? You take a test, you get nervous, right? And you forget things you already know. So I say that to my students all the time. Don't forget things you already know. And what I really mean is just don't be so nervous you mess up on something like 10 plus 4. Right? But if you show this step, at least I know you knew what to do. So it's a good step to show. Not necessary. If you told me you did that in your head, I'd believe you. But if you put 13, then I'll go, where did they get 13 from? But if you show me 10 plus 4, then I say, oh, they just can't add 10 plus 4. All right, so then c to the 6th and c to the 7th. So this is going to be c to the what? 6 plus 7. Notice each c has its own exponent here. That's the way all these work. Each m has its own exponent here. And then up here, each x has its own exponent, right? So when each variable that's a like base has its own exponent and they're all multiplied together, you add the exponents. So that's c to the 6 plus 7, which is going to be c to the what? 13th. And then the p's here, p to the 12th times p to the 3rd. Again, each p has its own exponent. So I'm going to say p to the 12 plus 3 power, which is p to the what? 12 plus 3 is 15, so p to the 15th. Don't do this because powers are raised. What I typically do is I go right through halfway through my variable. And if your power is any lower than that, then it's too low. Okay? So, on the one I just wrote down, if I go halfway through it, see how the 15 gets slashed? That means it's too low. If it slashes, it's too low. So you can even do that mental check on your paper when you write it down. Make sure that the power is raised. Not such a big deal when it's 15, but when it's fractions of power or something, they're a little more complicated, then it makes it more difficult. So you better make sure you get that done properly. So y times y to the 12th. This is going to be y to the what plus what? I don't know why I put an equals there. Equals. This is understood to be a 1. We don't write it, but it's there. But here we go, 1 plus 12, right? If we're showing the step, which is y to the 13th. The whole reason I did that, I wanted you to see that was the first power. If you just have a y, it's 1. It's not 0, it's 1. If you had 0, you wouldn't see any y's. Anything to the 0 power is 1, remember? So there it is. All right, y to the 13th. And then x squared times x to the 4th times x to the 7th. So here we have 3 of them, but each x has its own power, so we just add those together. So this is going to be x to the 2 plus 4 plus 7. So what is 2 plus 4? That's 6, right? So this is going to be x to the 6 plus 7, which is x to the 13th. And you don't have to show all those steps, but I'm just, again, going through it, showing you where it comes from. All right? So 2 plus 4 is 6, and then 6 plus 7 is 13, so x to the 13th. Didn't mean to have 2 13s there in a row. Just happened, all right? And then you can expand it out. You can have 5x times 4x, and I want you to notice the difference. I didn't put this in parentheses, but it means the same thing, right? There's nothing between this x and the parenthesis, so it's being multiplied. There's nothing between these parentheses, they're being multiplied. There's nothing between these, they're being multiplied. If you've already watched my addition and subtraction videos, right, we said, hey, there's a plus in between here, we're adding, or there's a minus in between here, we're subtracting. Here, there's nothing between there, so you're multiplying. So then what is 5x times 4x? Well, look, we all know what 5 times 4 is. It's 20. It's the x times x that's new here, right? There's a 1 and a 1. Understood 1. So then what do we do when we multiply like bases? We add the exponent. So it's going to be x to the 1 plus 1. So 20x squared. And there's your final answer for that one. 20x squared. That's your final answer for that one. And the next one, 10x times 5x cubed. Now, this is a little more obvious. It's got the parentheses, but the thing that throws people off sometimes is this. There's nothing between there. You're just multiplying. So what is 10 times 5? Right? And by the way, let me note this. This is a single term times a single term, a monomial times a monomial. This is a monomial, one term, one term. There's 2 factors, 10 and x, and here 2 factors, 5 and x cubed, but it's one term times one term. That's why you can do this way. So you multiply the 10 times the 5 and get 50. And then you say x, and there's a 1 there. So x to the what? 1 plus 3 is 50x to the 4th. Now, I want you to get to the point, if you're not there already, of being able to say 50x to the 4th without writing this step down. I want you to be able to do, okay, that's a 1 understood. So 1 plus 3 is 4. And you go straight to that part. And don't show me all the steps in between. So then here, again, one term and one term. I know there's a minus here, but that's a leading negative. So it doesn't change the fact that it's one term. It's still just one term. So a negative 8 times a positive 2 is negative 16, right? A negative times a positive is negative, and 8 times 2 is 16. And then we have n to the 3rd and n to the 4th. They're like bases, so we say 3 plus 4 on the power. So negative 16 n to the 7th power. And that's our final answer for that one. All right, so let's look at just a few more maybe. Oh, it brought me a line there. Hope it doesn't mess up. So 3y times 4y to the 4th. This is very similar, right? So then, again, one term and one term. So 3 times 4 is 12. And then we say y to the 1 plus 4 is 12y. And many of you wrote down 12y to the 5th already, and that's great. 12y to the 5th. And then here, this is still one term. I have 2 variables in it. Okay, I went ahead and decided to address that here, right? So you particularly may not see this in your class at this point if you're watching this video, but this is out there. It does exist. This is still one term, and so is this. This is still one term. So then, really, I'm still just doing negative 2 times negative 3. What's the negative times the negative? Positive, and 2 times 3 is 6. Then we have x and x cubed, so it's going to be x to the 1 plus 3. You got a 1 there, right? So then 1 plus 3. And then you got y to the 7 plus 9, right? Those are a little more obvious because they're both written there. So this is going to be 6x to the 4th, y to the 16. 7 plus 9 is 16. So 6x to the 4th, y to the 16th power, and you are completely done with that one. And then this one, look, I just came up with something crazy. You have m, n, and p, m, n, and p. But look, each one of those things is one term, and one term. This is like the one on the page before with the x and or the 2 pages is x to the whatever, x to the whatever, x to the whatever. Still the same thing. You're still multiplying them. So we have a negative times a 2 times a negative 5. Since they're all one term, we take care of coefficients, then we take care of m's, then we take care of n's, then we take care of p's. You take care of one factor at a time if it is one term times one term, which is what all these are. So then a negative times a negative is positive, and 2 times 5 is 10. So that whole thing just becomes 10, a positive 10. Then we have m to the 1st, m to the 5th, and m to the 11th. So we have m to the 1 plus 5 plus 11, right? And then we have n, we have what? 6, 4, and 6 plus 4 plus, this a 1? So 1, and then p, we have 1 and 1, right? So we have p to the 1 plus 2. So now we just need to simplify those things. This is going to be 6, right? So then that's going to be 10 m, and 6 plus 11 is 17. N's, 6 plus 4 is 10. So it's going to be n to the 10 plus 1 is 11. And then p to the what? 1 plus 1 is 2 plus 2 is 4. So 10 m to the 17, n to the 11, and p to the 4th. And that is the final answer for that one. And that one's kind of crazy. It's big. It's got variables all over the place, and it's got 3 things being multiplied, but they're all monomials. They're all one term. Sometimes students get confused when they see something like this. They think, oh, I have to FOIL. No, this is all one term and one term. You only FOIL when it's 2 terms times 2 terms. All right, and I have a video for FOIL. It's called FOIL plus more. It's got FOIL and then a little bit more in it than FOIL. All right, so I hope this helps out with multiplying like bases.